Hello everyone, I am Dattatreya Nikam. Welcome you all on our channel eFunda. New day, new topic, and our today's topic is radio detection and ranging, that is a radar system part 16C. And if you are new to our channel, then please visit to our channel eFunda and watch all the videos created related to the topic of engineering, instrumentation and control, fundamentals, engineering, procurement engineering, telecommunication engineering, project and career. And don't forget to subscribe to our channel to get latest notification of upload of our new video on our channel eFunda. So let's begin with our today's topic, that is radio detection and ranging radar system part 16C. Introduction to radar system. Radar detection and ranging is a detection system that uses a radio wave to determine the distance, that is a ranging, angle and radial velocity of object relative to the site. It can use to detect aircraft, ships, spacecraft, guided missile, motor vehicle, weather formation and terrain. A radar system consists of a transmitter producing electromagnetic wave in the radio or microwave domain, and transmitting antenna and receiving antenna. Often the same antenna is used for the transmitting and receiving, and a receiver and processor to determine properties of the object. One can refer the figure where the radar is shown. Electromagnetic energy pulses are transmitted and getting reflection from the target and received as an echo that will give you the detection time. Similarly, radio wave pulsed or continuous from the transmitter reflect off the object and return to the receiver, giving information about the object location, speed, etc. One can refer below the figure or the installation of the radar systems, and similarly the information or graphics where one can see the sketch where the details are indicated. Similarly, the rotating type of the radar are being used on the ship for the radio detection and ranging purpose only. We will see the detail in next slide. It is very important to understand the functionality of the radar. For that, one should understand the components of the radar. One can refer below the block diagram and a figure where some parts are indicated. We will go through the details. Similarly, for better understanding, one can refer the block diagram through presentation where we have indicated the component: control system, output, transmitter, duplexer, receiver, signal processor, decision, data processor, display, radio antenna as well as the target. And similarly, where the complete closed loop system is shown on the right hand side, where the object, antenna, waveguide, transmitter, duplexer, modulator, master clock, signal processor, receiver and radar screen, where actually the visualized output will be seen. We will move ahead with the details of each component. Transmitter. It can be powered amplifier like a klystron, traveling wave tube or power oscillator like a magnetron. The signal is first generated using a waveform generator and then amplified in a power amplifier. Waveguide. The waveguides are transmission line for transmission of the radar signal. Antenna. The antenna used can be parabolic reflector, planar arrays or electronically steered phase arrays. Duplexer. A duplexer allows the antenna to be used as a transmitter or a receiver. It can be gaseous device that would produce a closed short circuit at the input to the receiver when the transmitter is in working condition. A receiver. It can be super heterodyne receiver or any other receiver which consists of a processor to process the signal and detect it. Threshold decision. The output of the receiver is compared with a threshold to detect the presence of any object in the environment. If the output is below any threshold value, the presence of noise is assumed. Typically, consider one block diagram where the components are placed in such a way so as to understand the functionality. Now we'll move on to further details of the radar system for better understanding. Radar system working. One can refer figure where radar antenna is shown transmitting the signal where the target is placed in the environment and the working will be done. Similarly, we will see the working. It operates by transmitting electromagnetic energy towards the object, commonly referred as a target, and observing the echoes returned from them. The targets may be the aircraft, ships, spacecraft, automotive vehicle, or astronomical bodies, or even bird, insects, and rain. Besides determining the presence, location, and the velocity of such objects, radar can sometimes obtain their sizes and shapes as well. Similarly, one can see how the echo pulses are getting transmitted from the target when the transmittal pulses are hit or in line with the target. This is how the radar system works. Now we will see various types of the radar systems for clarity and understanding in brief. Types of radar. Bistatic radar. Bistatic radar is a radar system that comprises of a transmitter and a receiver that are separated by a distance that is equal to the distance of the expected target. Most long-range surface-to-air and air-to-air missile employ the use of bistatic radar. Second, Doppler radar. A Doppler radar is a special form of a radar that employs the use of a Doppler effect, that is, it is a change in the wavelength or a frequency of a wave for a viewer who is walking relative to the wave source. This is simplified to produce velocity data about an object at a given distance. This is achieved by sending electromagnetic signal toward a target and then analyzing how the object motion has affected the frequency of a return signal. Third, monopulse radar. A monopulse radar is a radar system that compares the received signal from a single radar pulse against itself with an aim of comparing the signal as seen in a multiple polarization or the directions. The most common form of a monopulse radar is the adoption of a conical scanning radar, which compares the return from two directions to directly measured location of the target. Passive radar. A passive radar system is a type of a radar system that is designed to detect and track objects by processing reflections from non-cooperative source of illumination in the environment. These sources include such a high thing as a communication signal and a commercial broadcast. Passive radar can be categorized in the same class of the radar as the bistatic type radar system. Fifth type, instrumentation radar. Instrumentation radars are the radars that are designed to test rockets, missiles, aircrafts, and amphibians on a government and a private test ranges. They provide a wide variety of information including space, position, and the time both in real time and in a post-processing analysis. Sixth, weather radar. Weather radars are radar systems that are used for weather sensing and detection. This radar uses a radio wave along with the horizontal or circular polarization. The frequency selection of a radar depends on the performance compromise between the precipitation, reflection, and attenuation as a result of atmospheric water vapor. Some weather radars are designed to use Doppler shift to measure the speed of wind and dual polarization to identify precipitation types. 7. Mapping radar. Mapping radars are used to scan a large geographical region for geography and remote sensing applications. Because of their use of a synthetic aperture radar, they are limited to relative static object. There are some specific radar systems that can sense human behind walls thanks to the reflective characteristics of an human that are more diverse than the one found in construction materials. Navigational radars. The navigational radars are generally the same as search radar. However, they come with much shorter wavelengths that are capable of reflecting from earth and from stones. They are most common on commercial ships and other long distance commercial aircraft. There are various navigational radars that include marine radars commonly mounted on ships for collision avoidance and navigational purpose. This is all about radar system we have covered. Hope this video will be helpful to understand the concept of the radar. With this, we are concluding on our today's topic, and you can find our channel details as follows. If you are new to our channel, that is our YouTube channel eFunda, then subscribe to our channel eFunda and don't forget to press bell icon to get latest notification of upload of our new video on our channel eFunda. Similarly, you can follow us on a Instagram page. Similarly, you can follow us on our Facebook page as well. And keep watching our channel eFunda for various topics related to engineering and a project. With this, we can assure you this will help you to better your understanding on engineering and a project topic. Keep watching our channel eFunda. Thanks. Watch our channel for new day, new topic.